Hello, my name is Marinos Gemoridis and I am Site Reliability Operator Team Lead at Kaizen. I'm part of the team that both uses and maintains the Graylog cluster at Kaizen, and today we are going to introduce you to the journey of Graylog in our company, what were the major challenges that we encountered throughout the years and how we overcame those challenges with the help of the Graylog team. First of all, let's introduce Kaizen, who we are. Kaizen is an online betting company which operates in more than 16 countries across the globe, and it operates under two brand names, Stichiman and Betano. So why we needed Graylog in the first place? We needed a centralized logging tool in order to be able to visualize the logs that our applications were generating. We needed to retain those logs for a specific amount of time, most likely around 2 weeks to 1 month, and we needed to be able to search efficiently through those logs and also monitor the healthiness of our applications through those logs. So at around 2012, Graylog was introduced to Kaizen with the first creation of Graylog cluster. It was an open source version of Graylog, and we were using Elastic and an ElasticSearch cluster for indexing. At the start it was a very small cluster with very few nodes for both Graylog and Elastic, and a couple of MongoDB nodes. But throughout the years and based on the needs of the company, this cluster was keep growing, and it became bigger and bigger as the years were passing. But throughout the years and throughout the scaling, we started experiencing some issues with the current Graylog setup that we had. Especially during the last year, like 2023, we had a lot of issues with performance during high traffic hours. We had slow performance in our searches, and we even had pretty frequent disruptions of Graylog and Elastic clusters. When I say pretty frequent, like once per week or so. So those disruptions were usually happening during high traffic hours as well. And that was something that was causing a lot of issues, because we are using Graylog for monitoring purposes as well. And most importantly, it was leading to loss of logs due to the unavailability of processing at those times. So at the end of 2023, we decided to ask from the Graylog team for help to create a collaboration and to transition to the enterprise version in order for them to assist us with all those issues that we had, that we mentioned above. So there were 3 key factors that took place in this decision, and the first one was the redesign and the optimization of our Graylog cluster in order to avoid the above mentioned issues. The second factor was the necessity of some enterprise features that we wanted to use, such like the Illuminate package, the audit functionality, the filtering in our searches, And of course the 24/7 support for critical cases regarding the Graylog performance and the cluster stability. So the journey started by planning the creation of the new cluster. The first step was to evaluate the existing cluster from the Graylog team to see in what state our cluster was, and to analyze the traffic and the rate of the messages that we were sending towards Graylog and OpenSearch, ElasticSearch, sorry. And the Graylog team came with a proposal on what we needed in order to keep up with the rate of the messages that we were sending, and also in what versions of both Graylog, OpenSearch and MongoDB we should be using in order to have like the best performing cluster. The last step for the planning phase was the planning of how we're going to migrate the current setup that we had in our previous cluster into the new cluster that was going to be created. So we had several sessions with the team from Graylog in order to perform all those checks and to see how this is going to be implemented. So first of all, we created the new clusters in our non-production environments, and we started migrating the logs for those environments into a new Graylog cluster in order to see how the migration is going to go and what things we should be careful on when we were going to migrate the production cluster to the new one. And when we were sure that everything were fine in the non-production clusters, we moved on with the transition in the production cluster as well. So the new cluster was created, and gradually we migrated the setup to the previous setup to the new Graylog and OpenSearch cluster that was created. But still there was a lot of work to be done, and this work was in the form of optimization. So throughout the years we had several leftovers in our Graylog cluster that needed to be fixed, let's say, in order to improve the performance of the new cluster as well. In those 7 points were the ones that in our case gave the most gain to the performance of the cluster. So the first thing was to remove unnecessary replicas from index sets. So in our previous cluster we had like 35-40 different index sets, and we kept replicas in all of them, and we had a lot of replicas in all of them. So previously we had like 3 to 4 replicas in more than 15 index sets, and this was increasing the amount of shards in our OpenSearch cluster, and per node up to like 275 shards in each OpenSearch node. So that was a pretty big amount of shards per node and in general in the cluster. So we removed unnecessary replicas from index sets that we didn't need them to have such high availability. Also, we increased the amount of shards in very heavy index sets. We had specific index sets that were receiving much higher traffic than the rest of the index sets, So they needed much more shards in order to split this traffic in more OpenSearch nodes and eventually make it faster make them faster in the processing. So that helped a lot, but we had to also optimize the max index size in order to keep the shards in a in the recommended area. So before, in the previous cluster, we had indexes with shards that were exceeding the recommended 40 to 50 gigs per shard. And that was causing a lot of performance issues, especially when those active write indexes were rotating. So we went through one by one all index sets and we optimized both the number of shards and the max index size before rotation. Another part was the optimization of our pipelines. We were using a lot of pipelines in order to manipulate logs, and those pipelines were very resource hungry. So we had several sessions with the Graylog team in order to find, to identify the pipelines that were the most resource hungry, and we optimized the expressions of those pipelines in order to use functions that are lighter and they are, without having any impact on the functionality of the pipelines. Another part that also gave a lot of performance boost was to remove unnecessary or unused stream rules. Throughout the years, we kept adding more and more stream rules in our streams, which were gradually had impact in the performance of the streams as well. So we did a cleanup of those stream rules, and we also improved let's say the expressions of those stream rules in order to have more efficient queries that will consume less resources when executed. That was the first part of the optimization, and while we were getting deeper and deeper into the performance of the new cluster, we proceeded to two major changes which had the biggest impact in the performance of the cluster. And the first one was to change the output batch size from the configuration in Graylog. So we ended up identifying an issue with how many threads we were using in our OpenSearch nodes. So we saw that we were sending very small batches of logs towards OpenSearch, and those small batches were occupying, each batch was occupying one thread in an OpenSearch node. So with Graylog team, we calculated the optimal batch size for our case, which was the 20,000 logs per batch, which is also dependent on the size of each of those logs. But in our case, the 20,000 batch size worked pretty well and increased the performance of the cluster very much, It also reduced the amount of threads that we were using across OpenSearch nodes, and it also helped very much with the processing times. And the last optimization that we did was to min-max the process buffer processors and the output buffer processors in Graylog in order to not create any bottleneck in the processing in the first part of Graylog processing. And this allocated the CPU of Graylog nodes much more smoothly, and the end-to-end journey of a log was not impacted at all. So in general, with the creation of the new cluster, with the transition from Elastic to OpenSearch, and with the upgrades in the newer versions from Graylog and OpenSearch, and the above optimizations, we had huge performance increase. So we had better performance in peak logging hours. We didn't have any major Graylog or OpenSearch outages for months now. We have very fast processing of logs. With the previous cluster, it was around 5 seconds on average to process a message, and now we are down to 2 seconds on average, always dependent on the amount of traffic that we have, but much faster than it used to be on average. Our searches, and especially the searches that go way back, like 2 weeks back, are much faster. But the biggest gain of the whole collaboration and the whole creation of the new cluster and the optimizations was the knowledge that we got from the Graylog team about how Graylog and OpenSearch operate in high availability and high performance environments. So now we're going to move to the scale overview and how big our cluster is right now and how big it was previously. So right now in Kaizen we process around 15 to 20 terabytes of logs daily. So we have around 550 to 600 microservices that are constantly generating logs, either error logs or informational logs. And we want to keep those logs for around 14 days. So we end up with around 250 terabytes of processed logs per month, and we keep around a bit less than 200 terabytes of logs stored at any given time in our cluster. The most important part of a large-scale cluster, though, it's not only the amount per day, but the rate that those logs are getting generated. In Kaizen, we have uneven rates of logs generation, because our log generation is heavily dependent on the traffic, and as you can imagine, a betting company's traffic is getting skyrocketed every time we have like a major sportsbook event, like a big match, Champions League or major sportsbook events. So the log generation is going up and down depending on the traffic that we have in our sites. So as you can see over here, we may reach up to like 750,000 messages generated from our logs per second. So this is a huge amount of logs that are getting generated, and we need to be able to process those logs as fast as possible. So one of the biggest, let's say, gains of this journey of transitioning to the enterprise version and the creation of the new cluster and the optimization was that we are able to withstand that kind of messaging spikes, which we were not able to do previously. And the last part of a large scale cluster, the last key factor of a large scale cluster is the real-time processing, and this is something that it is crucial for us because we use Graylog, as we're going to see, for monitoring purposes as well. So the real-time processing was one of the biggest factors in all the optimizations that we did in our Graylog cluster. So over here, for example, you can see that right now we are on average on around 2 seconds in the process time, compared to the 5 seconds that we used to be with the previous cluster. So the previous setup of our Graylog cluster at the end of 2023 was looking like this. We had like 3 Mongo nodes, 17 Graylog nodes with 20 core seats, and 60 Elastic nodes with 60 core seats and 4 terabytes of local SSD. This is by the end of 2023, before the new cluster. And the new one is a bit pumped up, as you can see. We still have like 3 MongoDB virtual machines with 20 Graylog nodes right now, but with a huge bump in the cores. We went up from 20 to 40 cores, and 60 OpenSearch nodes with 20 cores each and 6 terabytes of local SSD. You can see that the increase is pretty huge, especially in cores. So in total, the new cluster is around 1,100 more, needs 1.1 thousand more cores than than the previous one, and this is mainly driven by the fact that we need the fast processing, and we need to allocate to process as fast as possible all the logs that we are receiving. The increase in the storage it was mainly preemptive, because we want to be able to keep extra logs extra logging needs that may come in the near future. So new applications are going to start logging. We are constantly increasing in customer base, so we're going to have more and more generated logs. So we want to have like a healthy free space in order to be able to keep those logs while we are scaling the infrastructure of Graylog as well. So now let's move to the use cases. In Kaizen, we have like 4 main use cases. We use Graylog for investigation, for production issues. We use it for real-time monitoring, for application debugging, and for customers' activity logging. So the investigation of production issues and the application debugging, sometimes it is the same thing, but sometimes it is a totally different thing. So especially when we have like a production issue, the investigation is on the live logs, and especially on the active write indexes. We are searching logs for the past 5 minutes, 10 minutes, something like that. For application debugging, we're using logs that may go like 1 week ago, logs that are not high level enough in order to be tackled from real-time monitoring. So usually our engineers and developers are using application debugging logs in order to find any issues with our applications. And for the customer's activity logging, we use the customer's activity, all our customer's activity is getting logged in order to be able to handle any potential issue a specific customer may have, or in some cases we need some logs for regulatory purposes, which are mandatory. So we have around 380 active Graylog users, and this is a number that may go up and down depending on if we have like a production issue or not. We have like 20 users that are using Graylog in a very heavy manner, and I am one of those 20. We are using very heavy boards for live monitoring mainly. We have around 70 people that are using Graylog for tactical overviews of core components, and this means that they are checking spikes of logs that may occur throughout the day. We have around 100 people that are using it mainly for root cause analysis. So when we have like an issue in our production with a specific service or with multiple services, those people are searching throughout the logs in order to find out what started this issue. And we have like 200 engineers and developers combined that are using Graylog for health monitoring, for debugging of the applications that are live in production, or maybe applications that are not live yet in production and are in testing phases in production. So they are using it in order to debug those applications. So as you can see over here, the pie chart is a bit misleading, since it shows that Graylog is mainly used for health monitoring and debugging. Actually, the heaviest usage is being performed from those 20 people, the heavy board usage people, and from the 400 to 600 searches per minute, around 80 to 85% of those searches that are executed at a normal flow are coming from those 20 people that are using Graylog for monitoring purposes as well. And this number of searches per minute is getting bumped up depending on if we have like an issue or not. So when we have an issue, more people are getting engaged, so they're trying to search in Graylog for specific error logs, for specific information logs in order to identify any issues. So here, for example, you can see like a real-time monitoring board. It has like multiple widgets. Each of those widgets has its own query, and it's executed every 5 or 20 or 10 seconds. And For example, this board provides like a whole overview of how all those 550 applications are performing at a specific time. Those logs, for example, in this board, those logs have a specific, let's say, urgency. They are only urgent logs, logs with level 3 or higher. So we're not we're not monitoring information on logs, only logs that indicate an issue. Another board that is heavily used and also has like a visual representation for the source and the facility of the error generating. And now we're going into our final part of the presentation, which is what are the things that we're going to do moving forward. We have an ongoing communication with the Graylog team, and we want to scale and optimize our cluster even more in order to withstand more than 1 million logs, generated logs per second, without at the same time having any impact in the processing time. And this is something that the Graylog team is helping us with in order to find what kind of scales we need to do and what kind of extra optimizations we need to do, what extra configurations we need to do, and so on. We're also going to upgrade our Graylog cluster to version 6.1 at early November. And we are also in the testing phase of Illuminate feature for our network logs in non-production environments at the moment, which is also something that is going to be implemented in the production environment as well, probably during November. So, thank you very much. Thank you for the attention, and we hope you enjoyed our journey with Graylog so far, and looking forward for the next Graylog Go as well.